create a centralized restaurant and food review website in NTU by using different deep learning techniques. First, we will implement LSTM and BERT deep learning model for the sentiment analysis review. Second, we will create a path speech algorithm for the adjective-noun pair extraction to automatically generate the review text. Last but not least, we also train a ranking model by using the RankNet algorithm for the re-ranking of food review search result in our food review search system. So moving on, the first objective in our research, which is sentiment analysis. One of the most important requirements for any machine or deep learning task is to have high quality data set. In our project, we use the GAP dataset, which is a widely recognized benchmark in the deep learning community. This dataset consists of 750,000 unique reviews about food and restaurant. To build our model, we mainly focus on two attributes of this dataset. First is the text field, which is the review text, and second, the star field, which is the rating of the review, ranging from 1 to 5. So for these two figures, right, you can see the statistic of our dataset. From the first figure, we can see that most reviews have less than or equal to 500 words, which will be used as the sequence length in our model design. Whereas from the second figure, we can see that most reviews are skewed to the positive rating. And the sentiment analysis task in our research is to predict the rating of a review. As such, there are two promising deep learning models that we can use. The first one is the LSTM model, and second one is the BERT model. So before going deeper into our model design, let's first talk about work embedding. So as for anyone who doesn't know, work embedding is really powerful. It can represent words and documents as meaningful vectors. So essentially, a work embedding can be trained as a part of a deep learning model. Therefore, in our proposed LSTM model design, we use the global vector 50-dimensional work vector for the embedding layer. Next, we also use a bidirectional LSTM layer of size 100, followed by a 1D global mask pooling layer and a hidden layer of size 50. In our design, we also use a dropout layer of value 0.1 to prevent our model from overfitting during the training process. And finally, in the output layer, we use the softmax function for the multi-class classification of the review rating. On the other hand, regarding our BERT model design, as BERT has already been presented on a very large corpus of unlabeled text, we only build a simple architecture, as you can see in this picture here, to show that BERT can still achieve promising results without any complicated architecture for any specific task. So several parameters of our BERT design include a BERT embedding layer of size 256. And similar to our LSTM design, a dropout value of 0.1 to prevent the model from overfitting, and the softmax function for the output layer. And subsequently, we then train our LSTM model for 4 epochs by using 700 data, and then test it with the rest 50,000 data points. So as a result, our LSTM model achieved an accuracy of 66.76%. On the other hand, by using the same training and testing dataset, our BERT model only needs to be trained by 2 epochs to achieve a higher accuracy of 70.52%. So overall, we can see that our BERT model has outperformed the LSTM model by nearly 4%. So despite having a simple architecture, our fine-tuned BERT model is able to achieve promising results. However, our LSTM model is still a very good candidate for slower machine that still need to perform this analysis task, as the 4% difference is not that much. So now we move on to the second objective of our presentation, which is the review text generation. So let's first talk about our motivation behind this objective. So as we all know, an online review website usually offers a vast number of reviews about an item, which usually extend beyond the user ability to skim through every line of review. Furthermore, most of these reviews are also unstructured and vary in length, writing style, and format. So all of these problems prevent users from easily obtaining helpful details about any item from online reviews. However, there have been some attempts to solve this problem, and the review spotlight system is proposed to use extracted adjective-noun pair as review tag to serve as a summary of a review. So as you can see in this second figure here, these are some of the review tags that are extracted from review. So by just focusing on this review tag, we can have a brief understanding of how good or how bad the restaurant are. But so in particular, this adjective noun pair is extracted by an algorithm in the review spotlight system that pair every noun with the closest adjective. However, the review spotlight implementation is actually incorrect because have a look at this example here. From this beautiful restaurant is awful. The review spotlight algorithm will output the beautiful food pair as a result of pairing a noun with the closest adjective, which is incorrect. So to put it correct, this noun pair extraction should be the process of extracting every noun in a document along with the adjective modifying them as well as negation words. So therefore, the correct output should be awful food and beautiful restaurant. So therefore, to better improve this system, we want to create a better part of speech algorithm that can fulfill all of these objectives. So in detail, our part of speech algorithm is built based on the principle of stacking and dependency parsing by using spacing, which is an library for advanced NLP in Python. So by using spacing, our algorithm can detect if and noun as well as their relationship in a sentence. So for instance, let's have a look at the previous example. The food from this beautiful restaurant is awful. Our algorithm can detect beautiful and awful as the two adjectives as well as their relationship with restaurant and food respectively to correct output beautiful restaurant and awful food. So by that, we also conduct an experiment to evaluate the performance of the algorithm, and the results show that 95% of more than 500 extracted adjective noun pair are indicated as valid by a group of evaluators who are either fluent in English or experienced in the NLP field. So as you can see, our algorithm is not completely perfect, but like it cannot deal with the incoherent and grammatical error, which can lead to incorrect US stacking and dependency parsing. So for the review bad food, good owner, readers awesome. Our algorithm will incorrectly output bad owner and good owner. So as you can to explain this, as you can see from this figure here, you can see the bad adjective is connected to the owner adjective instead of the food noun, whereas the awesome is interpreted as a verb instead of an adjective. So to put it correct, we can put a comma or a stop between food and good and replace those with is. So by fixing this, it would correctly output our desired review text. So now we move on to the next objective of our research, which is food review search in learning to rank. So first of all, what is learning to rank? Learning to rank refers to the machine learning method, the ranking model for information retrieval system. The ranking model will learn to re-rank the retrieved document in a similar order to ranking training data. There are many available ranking algorithms that we can use, but in this project, we will use the RankNet algorithm because it is powerful and also supported in some. So with regard to the development process of our RankNet model, it consists of four major steps. First, in the data preparation step, we create a set of query and document from the original yet reviewed dataset. And then in the second step, we define feature and their similarity scoring function so that our ranking model can compute feature value and then perform the query ranking based on this value. And next, in the third step, from the previously created query and document, we create the feature dataset, which include the feature value as well as relevant label for every query document pairs. And finally, in our experiment, by using the feature dataset that we have created in the first step, we then can train and test our RankNet model. So after a very long process of developing our RankNet model, you may wonder what is its role in our search system. So to better understand it, let me introduce to you the learning to rank search query process. So in detail, when a user enter a query, our system will extract feature from that query and then pass it to the source server. The source server will then retrieve document by using a simple, let's say, similarity scoring function, and then compute feature value for each of the query document pair, and then the retrieval result in the original order, and then fed into the RankNet model along with the feature value to perform the query re-ranking. And then our RankNet model will output the retrieval result in the new order defined by itself. And finally, our system will return the retrieved data back to the user in the new ranking order as the query response. So to better explain learning to rank such query, I'll show you a simple example here. So for the query not bad food, our system will initially retrieve document by using a simple similarity function. Let's say BM25 in this example, which is a classic retrieval method. So as you can see in this initial result, document 1 is ranked higher than document 2 and document 3 because it has more terms in common to the query, which is bad food. So from the initial result, our source server will calculate the feature value, as you can see in this first step here. So for you to better understand it, the first column corresponds to the textual similarity computed using BM25, whereas the second column here corresponds to the semantic similarity, which is computed by using BERT embedding in our system. So this feature value will be used by our RankNet model to perform the re-ranking and calculate the final score to make the re-ranking based on this score. So as a result, we will have the final ranking as in the last step and in the correct order that we want, which is document 2, document 3, and finally document 1. Oh, so sorry. So document 1 here should be bad food, not good food. And so by using this learning tool and search query, we can then also conduct an evaluation of our approach, and the results show that our approach by using the RankNet model has improved the performance by between 29% and 46% compared to BM25 and TF-IDF on all metrics, as you can see in here. And then one intuitive explanation for that is that our RankNet model evaluates both textual and semantic aspect of a review, as well as the full category information to find the most similar review, while PM25 and TF-IDF only consider the textual information. So this proves that our approach is more effective and very promising for the real-world application. So by saying that, in our project, we also create a centralized restaurant and food review website named NTU Food Hunt. And the technology stack behind this website includes Django, PostgreSQL, SOAR, and React. So this website will showcase all of our work so far in this research, including sentiment analysis of food review, review tag generation, and food review search using learning to rank. So first, for the sentiment analysis of food review, we incorporate our LSTM and BERT model for sentiment analysis of food review. As you can see in this first picture here. So for every review in the system, our model predict the rating of that review and then display it along with the review, as you can see here. And so for the rating, 1 to 2 star indicate negative review, which is colored as red. 3-star rating indicate neutral review, which is colored as yellow here. And 4 to 5 star indicate positive review, which is colored as green. So in addition to this one, we also calculate and display the average actual user rating and the average predicted rating, so that we can have a brief understanding of how well our model perform on average. And secondly, for the review tag generation, we integrate our part of speech algorithm to automatically extract adjective noun pair from all review. So as you can see from this picture here, these adjective noun pair are displayed in the form of and also associated with the sentiment color green, yellow, and red. So this will help user easily get a quick overview of public opinion about any restaurant or food store in our website without reading all line of reviews. And finally, in our system, we also allow users to search for any review of their interest. We provide different search methods so that the user can compare the performance between these methods. And indeed, we incorporate our RankNet model for learning to rank search. For example, as you can see in this figure here, for the search query awesome food, our system will return the most similar review in terms of semantic. So you can see here, the food was great. Is close to awesome food as well as the good food overall. And so finally, to conclude my presentation, I would like to give you a brief overview of how well our accomplishment is so far in this project, as well as introduce to you future enhancement of our system. So in conclusion, we have improved the entire system by using different deep learning techniques for various components of the website. First, our BERT model achieved result of 70.52% and outperformed the LSTM model by nearly 4%. Secondly, we have created a bias algorithm for review text generation, which achieved the performance result of 95%. Last but not least, our proposed approach by using the RankNet model for food review search outperformed both BM25 and TF-IDF by between 39% and 46% on map at 135 and MRR metrics. So as you can see, our system is now fully functional with some advanced features. However, there is still room for improvement, and the first possible enhancement is aspect-based sentiment analysis, which categorizes review by aspect and identify the sentiment associated with each aspect. Furthermore, we can also improve the food review search system by collecting more data and investigating all the ranking algorithms, such as Lambda Rank and Lambda Mark, which are also very promising. And finally, a mobile application would also be useful and convenient for a large number of mobile users nowadays. So, yeah, I conclude my presentation, and the floor is open to.
Okay, thanks, Carla, for his presentation, and feel free to raise up any questions and send it in the Zoom chat box or other platforms like. And you will have around 3 to 4 minutes for your Q&A session due to the delay of the start. So please feel free to raise up any questions.
I think some people are mostly clear about what I said, or maybe not yet. So, sorry. I think maybe if people is not asking now, I think I can send out my email or my contact. So if anyone have any question later, they can feel free to email me.
Yeah, okay, there is a question on the ground. How were the predictions evaluated? She means the objective function.
Sorry, can you say like which objective are you referring to? Is it analysis or review text generation? Oh, so as you my presentation, right? I use the game data set. So basically, I split the data set into two sets, training and testing. So for the testing, right, we use the basic matrix to test it, like which is to see what is the accuracy of the prediction, and also look at the loss value to see how well the model will perform. So to repeat it for you, our LSTM model achieves the accuracy around 66% on the accuracy metric, whereas the BERT model achieves an accuracy of around more than 70%. Yeah.
Okay, thanks for the elaboration. So yeah, there's a following question. So you use a loss function for guess and actual value.
Yes, so basically in our model, right, we use the ADAM optimizer and the loss function. I think is the categorical function to make the model that can learn to predict the rating on the range from 1 to 5. Actually, it's 0 to 4, but we can scale that back to 1 to 5. Yes, it's the supervised algorithm. Yeah.
Yeah, okay. So due to time limit, this should be our last question. Thanks for the presentation. And coming up, we will have two following, not only two, but we will have two presentations. One is one brought by Kiran Bodhipati and another on the 2 p.m. After that, from 12:30, we'll have a guest speaker, Dr. Bolly, and she will share with us her ideas about AI for a better world. So thanks so much for you coming. And if you want to join the next presentation, you can leave and join quickly. Yeah, thanks.